Is audio video clear? Am I audible? Right. Right. Am I audible? Now, yesterday we have discussed this problem. Let A be n cross n matrix and A square equal to I. We got unique solution, right? No voice. Right. Observe next column. Matrix A, 3 cross 3 matrix with rank 2. Matrix is 3 cross 3 with rank 2. Then Ax equal to 0 has trivial solution only when x equal to 0, only one independent solution, or two independent solution, or three independent solution. Which one? Observe here. Matrix A is 3 cross 3 with rank 2. Observe. Matrix is 3 cross 3 with rank 2. So rank of the matrix is 2. Now number of variables, number of columns. Okay, number of variables equal to number of columns. Yesterday I have explained you clearly. Now rank of the matrix is 2 and the number of variables are 3. Therefore number of independent solutions equal to free variables. Free variables equal to total number of variables minus rank. So 1. Answer is 1. Next problem. Observe. Matrix A n cross n with rank R. Kamalesh Kumar, don't divert the concept. Yesterday I have explained you clearly why number of columns are number of variables. Okay? If your intention is different, better to leave. Concentrate on the content. Observe. AB n cross n matrix with rank R. Ax equal to 0 has P independent solutions. Independent solutions are P. It is not my assumption. They have provided. Okay. Where P is, what is P? Number of independent solutions are P. Then how to calculate independent solutions for an n cross n matrix with rank R? Yes, Vijay, it is nullity. P is nothing but nullity. How to get nullity? Total number of variables minus rank. Total number of variables are obtained by number of columns. Number of columns are n. So n minus rank. Rank is R. It is given in the data. Therefore R. Nullity is nothing but number of independent solutions. Number of independent solutions are total number of variables minus rank or total number of columns minus rank. Whenever you are writing system of equations, While writing equations, first column you are going to maintain coefficients of x1, second column coefficients of x2, third column coefficients of x3. That's why number of columns always equal to number of variables. Okay, next. A set of linear equations represented by the matrix Ax equal to B. The necessary condition for the existence of a solution for this system. If you have conceptual idea, then only you can able to answer. Whether option C or option A, option B, wait. Don't give the options in the comment box. Don't use lottery system. If you know the concept, then only you give the answer. Otherwise, keep quiet. Let me explain. Set of equations represented by matrix equation Ax equal to B. While I am explaining, concentrate here. The necessary condition for the existence of solution for this system. Okay. It is a non-homogeneous system. Okay. For a non-homogeneous system, solution exists means system is consistent. When a non-homogeneous system would be consistent, rank of A equal to rank of augmented matrix AB. Okay, we know that concept. Rank of A and rank of augmented matrix AB both are equal. Then only the system is said to be consistent system. Concentrate here. I am not explaining, just I am asking the questions. You apply, definitely will get the answer. Okay. Suppose A is 4 cross 4 matrix. Because let me explain. A is 4 cross 4 matrix. Suppose, what about AB? Tell me now. What about AB? 1 column extra. Okay. So 4 cross 5. 4 cross 5. Please concentrate. A is 4 cross 4 and AB is 4 cross 5. Just 1 column is extra. 1 column vector is extra than A. Okay. Now, rank always represents number of independent vectors. Number of independent vectors. Okay. Please concentrate. Number of independent vectors of A are, suppose 3. Suppose 3. Sir, why not 4? You can take 4 also. No problem. I am taking suppose 3. If number of independent vectors of matrix A are 3 means, what about dependent vectors? 1 na? Okay na? So 1 dependent. 1 dependent, 3 independent. Okay? There are 4 vectors, 1 dependent vector, 3 are independent vectors. Sir, rank of a matrix is 3 means 3 independent vectors. So those 3 independent vectors are row independent vectors or column independent vectors. Which one? Both. This concept we have already discussed. Okay. So number of independent vectors of A are 3. Number of independent vectors of A are 3 means number of independent row vectors are 3. Number of independent column vectors of A are also 3. Okay. Now come to matrix AB. What is the difference between A and AB? What is the difference between A and AB? Only one column, na? Only one column, na? So if this column vector is, now my question is, I am not going to answer, just I am questioning. If this column vector is dependent vector or independent vector? Think. Dependent vector or independent vector? 1 minute, 1 minute. Some of the students are giving dependent and some of the students are giving independent. I will explain. If it is dependent, what is going to be happen? If it is independent, what is going to be happen? 1 minute, observe. Suppose if the silence please, please. Kulkarni, Basha, Manik Chaudhary, 1 minute, observe. If this vector is, suppose if that vector is independent vector, then compulsory rank of AB increases or not? Increases, because already in A you have 3 independent. So here we have 3 independent. If this fourth column, whatever extra column you have, if that extra column is independent vector, then number of independent vectors increases. If the number of independent vectors increases, rank increases than A. If rank of A and rank of AB are different, then can we get the solution? Can we get the solution? No, not at all. Okay, catch my point. So if you want to get the solution, compulsory rank of A and rank of AB must be equal. When it is possible to be equal, if that extra column must be dependent column, if that extra column must be dependent column, if it is dependent, then automatically rank of A and rank of AB would be equal. Catch my point? So the correct answer is B must be linearly depend on columns of A. That is the logic. Very conceptual problem. Understood? So rank of A and rank of AB would be equal only when whatever difference between A and AB, what is the difference in that column B? If B is depending on A, then only you will get rank of A and rank of AB are equal. Oh Kameshwar, abhi tak that difference only I have explained. If B is independent column, then what happened? Rank of AB differs with rank of AB and rank of A are not equal. If they are not equal, there is no possible solution. Okay? Got the point? Next problem. Observe next problem. Observe. Excellent question. Let C1, C2, Cn be scalars, not all 0. Mr. Aniket Sharma, in the last problem, whether it is n cross n or n cross n plus 1, doesn't matter. Doesn't matter. Rank of A, suppose 10. Rank of AB should be 10. When it is possible, if B is depending on A, then rank of A and rank of AB would be equal. Otherwise, please read the problem. I am not interested about the answer. You have to understand the process. How to process the given data, how to identify the keywords. Let C1, C2, you are not getting the question, I am explaining. Concentrate here. Let C1, C2, Cn be the scalars, not all 0. That is the keyword. Such that sigma Ci Ai equal to 0, where Ai are column vectors in R power n, where Ai's are column vectors in R power n. Consider the set of linear equations Ax equal to B, where A is equal to A1, A2, An, and B is equal to sigma I equal to 1 to n Ai. Then the set of equations has. If you would like to solve this problem, you have to recall one definition. I have given 4 definitions, 4 methods to examine whether the given set of vectors are independent or dependent. One is comparison method, another one is determinant method, third one is rank method, fourth one K1, K2, Kn, K1, K2, Km be scalars, and x1, x2, xm be the vectors. Then the linear combination k1, x1 plus k2, x2 plus km, xm equal to 0. If ki's are not all 0, then the vectors x1, x2, xm are all, the set of vectors are linearly dependent. Okay, if all ki's are 0, k1 0, k2 0, k3 0, km 0, then linearly independent. Okay, the problem is designed on that definition. Okay, concentrate. Here, while I am explaining, concentrate. Very simple. Instead of K1, K2, Kn, they have given C1, C2, Cn. C1, C2, Cn. Be scalars. Sir, what are vectors? Instead of x1, x2, xn, they have provided a1, a2, an. a1, a2, an are vectors in R power n. You have to understand. R power n means n-dimensional vectors. A1 is in the form of n cross 1. A2 is n cross 1 vector. An is also n cross 1 vector. Sir, how do you know that? With this R power n, you can estimate. So, how many vectors are here? 1, 2, 3, n. N vectors of dimension n. So, n-dimensional vectors. When all your vectors are n-dimensional, n vectors of n-dimensional, with the help of these vectors, if you create one matrix, that matrix A would be automatically n cross n matrix. Na? Here, A1 is first column, A2 is second column, An is last column. So, your matrix is n cross n matrix. A is n cross n matrix. Okay. Now, What about AB? What about augmented matrix AB? Augmented matrix AB. Observe. अनिकेत शर्मा, प्रॉब्लम पूरा नहीं पढ़ेंगे, क्या लिख रहे हैं तो लिखेंगे उधर. Here A1, A2 are column vectors in R power n. They have mentioned. What you have written? Sir, they can be row also, na? He has mentioned column vector. How you can write row vector? Consider it. You have to consider every point you have to study. Otherwise, keep quiet. I have no problem. Other students will be diverted. They will be confused. Concentrate. A1, A2, An are all column vectors. N column vectors. It is not my assumption. It is given in the data. And also given that in the data, it is also given that B equal to sigma AI. Sigma I equal to 1 to n AI means what? A1 plus A2 plus A3 plus An. All column vectors summation gives you one vector. That vector is B. Okay. So I am talking about augmented matrix AB. In augmented matrix AB, A1, A2. If A1, A2, An are all column vectors, B is also a column vector. Right, like this. Because it is augmented matrix. So if it is, in the case of augmented matrix, how many rows you have? N rows. Okay, N rows. How many columns you have? N plus 1 columns. Please remember, here, this B is nothing but sigma AI. By this, definitely you will get one idea. Just I am explaining the data. Okay. N plus 1 columns are okay. N rows, N plus columns are okay. By the hint, sigma I AI, A1 plus A2 plus An equal to B means sum of A1 plus A2 plus An equal to B means, suppose if you apply one operation, Cn plus 1, n plus 1th column minus of C1 plus C2 plus Cn, then last column is going to become, if you apply column operation, last column is going to become completely zero column now. By that you can understand one point. What is that? What is that? B is depending on A or B is independent of A? B is depending on A. If B is depending on A, rank of A and rank of AB are equal. Catch my point? Because of this hint, we can understand that B depends on columns of A. If B depends on columns of A, rank of A and rank of AB are equal. There is a solution. If there is a solution, whether that solution is unique solution or infinitely many solution, we have to classify. How to classify? Observe. In the definition, they have mentioned, in the problem they have mentioned clearly, C1, C2, Cn, B scalars, not all zero. In the linear combination, in the linear combination of the vectors a1 x1, not x1, here x1 is vector, a1 is vector and c1 is constant. Okay, c1 a1 plus c2 a2 plus cn an, c2 a2 plus cn an, c2 cn an equal to 0. This is a linear combination. In this linear combination, c1 c2 cn not all zeros, not all zeros. If they are not all zeros, then the vectors a1 a2 an are linearly dependent. If the vectors are linearly dependent, matrix A is nothing but combination of vectors of a1 a2 an. If all the vectors are, if the set of vectors are linearly dependent, some vectors are independent, some vectors are dependent. That is the meaning. Okay, if the set is linearly dependent, then rank of A is less than n. If rank of A is less than n, rank of A is less than n. From this, you can write rank of A is less than n. How can we write this statement? By this statement. C1, C2, Cn are all not all zero. By that, you can write rank of A is less than n. Rank of A less than n is one equation. Rank of A equal to rank of B is another equation. The conclusion is rank of A equal to rank of AB less than number of variables. From 1 and 2, you can write rank of A equal to rank of AB less than number of variables. Therefore, infinitely many solutions. Understood? Avadesh, you have posted 7 times same message. Sir, please explain the hint of B. Hint of B is sigma AI. Sigma AI means A1 plus A2 plus AN. If A1 plus A2 plus AN, compulsory B is depending on A. If B is depending on A, rank of A and rank of AB are 100% equal. I will give one example. If I give the example, you will get clear picture. Now, observe, one vector is 1, 2. This is called A1. 2, 4. This is A2. Okay. Now, your name is question mark. How you can understand? B is sigma AI. Sigma AI means you have to add A1 and A2. 1 plus 2, 3. 2 plus 4, 6. Now, this is A. This is B. Now, AB. 1, 2, 2, 4, 3, 6. Okay. R2 minus R1. 2R1. Apply R2 minus 2R1. You will get 1, 2, 3, 0, 0, 0. What is rank of A? 1. Rank of AB is also 1. Why it is so? rank of A and rank of AB both are equal to 1. What is the logic? What is the logic? Since B is sigma AI, B is depending on A. That's why. If you apply column operations, no problem. If you apply column operations, C2 minus 2C1, C3 minus 3C1, again you will get rank of A is 1, rank of AB is also 1. Please remember, if you apply column operations, rank of A is nothing but number of non-zero columns. Rank of AB is nothing but number of non-zero columns. All the columns are proportional. Therefore, rank of A and rank of AB equal to 1 only. So, if B is sigma AI, you can understand that B is depending on A. Then only rank of A and rank of AB would be equal. Understood? It is not a method. It is example. Just for understanding purpose, I have given the example. Okay? This is conceptual analysis. This is by example you can understand. Ankit Sharma. If B is depending on A, then rank of A and rank of AB are equal. Understood? Now, observe the problem. Observe the problem. V1, a vector, column vector, 3 cross 1 vector. V2, 0, 1, 1, that is also a column vector. Let M be the matrix whose columns are V1, V2, 2V1 minus V2, V1 plus 2V2, not comma, this is plus, V1 plus 2V2. V1 is 1 column, V2 is 1 column, 2V1 minus V2 is 1 column, V1 plus 2V2 is 1 column. In that order, in the same order, whatever order they have mentioned. Yes, it has 4 columns. How many rows? 3 rows. Because 3 components na. V1 has 3 components na. So it is 3 cross 4 matrix. Matrix M is 3 cross 4. Then the number of independent solutions of homogeneous system of equations. How many number of independent solutions of this homogeneous system? Yes, nullity. To calculate nullity, first you have to calculate rank. Na? How to get rank? Tell me now. Apply the concept. Directly within 1 second you can answer. Rank 1. Na? Rank 1 kaisa ji? 2 V1, V2 are 2 dependent or independent? V1 and V2 are independent. Na? When V1 and V2 are independent, 100% 2 independent columns are available. Na? But 2V1 minus V2, that is dependent. V1 plus 2V2 dependent. Out of 4 columns, V1 independent, V2 2 independent and 2 dependent. 2 independent and 2 dependent. Nishant, answer is not 1. Answer is 2. Why? Because third column and fourth columns are dependent. First 2 columns are independent. Finally 2 column vectors are independent. 2 column vectors are dependent. Total 4 columns. 4 columns means 4 variables in your system. Out of 4 variables in your system, total number of variables are 4. Rank of matrix M is 2. Therefore, the difference is 2. Rank is 2. Number of variables are 4. Nullity is 2. So answer is 2. V1, V2, 2V1 minus V2, V1 plus 2V2. This is matrix M. You need not to write the entries and you need not to solve entire process. Just by conceptually, you can analyze. V1 is a 3 cross 1 vector, 1 1 0, 1 1 0, 1 1 0, 0 1 1, 0 1 1. Okay, so we can understand that there are 3 rows and 4 columns. 2V1 minus V2 and V1 plus 2V2. By applying suitable operations, automatically those columns become 0 columns. That's why 2 vectors are dependent and 2 vectors are independent in columns. So finally, you have 2 independent vectors. Therefore, rank of M is 2. Number of variables equal to 4. Because number of variables are given by number of columns, 4. Now, number of independent solutions equal to nullity. So final answer is 2. Understood? You need not to write 2V1 minus V2 and V1 plus 2V2, applying operations, finding rank, it consumes time. Okay? Now you got the idea about independent vectors. That's why you can write directly 2 independent vectors. Right. Observe next problem. Observe next problem. Alpha 1 1, 1 beta 1, 1 1 gamma. That is the matrix M. Alpha, beta, gamma is 1. Alpha, comma, beta, comma, gamma. Alpha, beta, gamma belongs to R. Belongs to R means real numbers. They are real numbers. X is a column vector of order 3 cross 1. A 3-dimensional vector. He has mentioned RQ. RQ means 3-dimensional vector. So Mx equal to 0 has infinitely many solutions. If trace of M is the system possesses infinitely many solutions, what type of system it is? Homogeneous system or non-homogeneous system? I am asking, homogeneous system or non-homogeneous system? Homogeneous system or non-homogeneous system? 100% homogeneous system. He has mentioned Mx equal to 0. A homogeneous system has, sir, why you are asking homogeneous, non-homogeneous? If it is homogeneous, infinitely many solutions means non-zero solutions, non-trivial solutions. Non-trivial solutions means that A equal to 0. I would like to use that. Sir, if it is non-homogeneous system, determinant equal to 0, we should not apply. We should not apply if it is non-homogeneous system. Yesterday I have given 2 examples also. Remember? You have to go by rank procedure, but not determinant procedure if it is non-homogeneous system. Okay? Now, that's why I am questioning, is it homogeneous or non-homogeneous? It is clearly homogeneous. That's why in homogeneous system, Non-trivial solution means determinant is 0. Trivial solution means determinant is non-zero. Okay, now it is homogeneous system. Mx equal to 0 form has infinitely many solutions. Whenever you have infinitely many solutions, you can understand that infinitely many is nothing but non-trivial. Non-trivial means determinant of m equal to 0. Reverse. Non-zero solution means determinant is 0. Trivial solution means determinant is non-zero. Reverse. Okay. So now determinant value of m equal to 0. What is m? Alpha 1 1, 1 beta 1, 1 1 gamma equal to 0. Expand determinant. Expand determinant. Alpha of beta gamma minus 1 minus 1 of gamma minus 1 plus 1 of 1 minus beta equal to 0. Alpha beta gamma minus 1 minus gamma plus 1. 1 minute. Here alpha. Alpha beta gamma minus alpha minus gamma plus 1 plus 1 minus beta equal to 0. Given that alpha beta gamma value 1, where in the data it is given here. Okay, therefore 1 minus alpha minus gamma plus 1 minus beta equal to 0. Therefore alpha plus beta plus gamma equal to 3. Okay, now alpha plus beta plus gamma is nothing but trace of the matrix. Now trace is nothing but sum of principal diagonal elements. Sum of principal diagonal elements is nothing but trace. Understood? So trace is 3. Next problem. The system of equations has non-trivial solution. Then the value of 1 by 1 minus a plus 1 by 1 minus b plus 1 by 1 minus c is 1 by 1 minus a plus 1 by 1 minus b plus 1 by 1 minus c is non-trivial solution means determinant is 0. Use the concept determinant is 0. Very good. The system of equations has non-trivial solution. Therefore, determinant value of A equal to 0. Determinant value of A equal to 0. Equate determinant A11, 1B1, 11C equal to 0. Now, I am going to apply the operations. C1 minus C2, C2 minus C3. Any problem? Now, A minus 1, 1 minus B, 1 minus 1, 0. 1 minus 1, 0. B minus 1, 1 minus C, 1, 1 C equal to 0. Okay? Next. Now I am expanding determinant. A minus 1 multiplied with, you can take common because I am expanding determinant. A minus 1 multiplied with B minus 1 into C minus 1 into 1 minus C minus second entry 0, that's why third entry, so plus 1 of 1 minus B into 1 minus C minus 0 equal to 0. Now, A minus 1 multiplied with B minus 1 into C minus A minus 1 into 1 minus C plus 1 minus B into 1 minus C equal to 0. Observe, some terms are A minus 1, some terms are 1 minus B, like that. Okay, for convenience, I am going to write A minus 1 into B minus 1 in the form of 1 minus A into 1 minus B. Here, A minus 1, I am going to write minus of minus plus 1 minus A into 1 minus C plus 1 minus B into 1 minus C equal to 0. Okay. Now divide throughout the equation with 1 minus A into 1 minus B into 1 minus C. Then you will get C by 1 minus C plus 1 by 1 minus B plus 1 by 1 minus A equal to 0. Do one thing. 1 by 1 minus A plus 1 by 1 minus B is there. 1 by 1 minus C is not there. That's why add 1 by 1 minus C on both sides. So C by 1 minus C plus 1 by 1 minus C plus 1 by 1 minus B plus 1 by 1 minus A equal to 1 by 1 minus C. Okay, continuation. 1 by 1 minus C plus 1 by 1 minus B plus 1 by 1 minus A equal to 1 by 1 minus C minus C by 1 minus C. LCM 1 minus C. Numerator 1 minus C. After cancellation 1. Therefore, 1 by 1 minus A plus 1 by 1 minus B plus 1 by 1 minus C equal to 1. 1 is the answer. Next column. x plus 2ay plus az equal to 0, x plus 3by plus bz equal to 0, x plus 4cy plus cz equal to 0 has non-zero solution. Then ABC are in arithmetic progression or geometric or harmonic or arithmetic geometric progression, AGP. Now, same concept, det A equal to 0 because non-trivial solution. 1 to A, 1 3B, 1 2A, sorry, 1 3BB. Mahima, the system possesses non-trivial solution means determinant is 0. Determinant equal to 0, not equal to, determinant 0. Reverse. Non-zero solution means determinant 0. Zero solution means determinant non-zero. 1 3BB, 1 4CC equal to 0. Expand determinant 1 of 3BC minus 4BC. Harshit, what is the use of free variable here? Huh? 2A of C minus B, A of 4C minus 3B, because you can apply operations. You can apply operations, no problem. Minus BC minus 2AC plus 2AB plus 4AC minus 3AB equal to 0. From this, we can write minus BC minus 2AC plus 4AC plus 2AC, 2AB minus 3AB minus AB equal to 0. So 2AC equal to AB plus BC. So 2AC equal to A plus C into B. Now 2 by B equal to A plus C by AC. 2 by B equal to 1 by C plus 1 by A. A, B, C are in harmonic progression. Two B equal to A plus C, arithmetic progression. B equal to square root of AC, geometric progression. 2 by B equal to 1 by C plus 1 by A, harmonic progression. Right? Observe this problem. The system of equations x plus 2y plus 3z equal to lambda x, 3x plus y plus 2z equal to lambda y, 2x plus 3y plus z equal to lambda x has a non-zero solution. First, my question is it homogeneous system or non-homogeneous system? Clearly, you know the concept. You know the concept. Now, tell me, is it homogeneous or non-homogeneous? Even though you know the concept, in some cases, you will be trapped. The problem is designed in that model. Observe, there is no constant term in your equation. Variable, 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 variable. Variable, 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 variable. Variable, 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 variable. All are variables. Nothing is constant. There is a typing mistake. This is not lambda x, lambda z. Last equation. Okay. It is homogeneous system. It is not non-homogeneous system. Only the thing is, they have given lambda x, lambda y, lambda z right side. There is no constant term in your equation. It is a homogeneous system. Okay. Send lambda x, lambda y, lambda z left side. You will get homogeneous equations. 1 minus lambda of x plus 2y plus 3z equal to 0. That is your first equation. 3x plus 1 minus lambda y plus 2z equal to 0. Third equation is 2x plus 3y plus 1 minus lambda z equal to 0. Clearly they are in homogeneous form because there is no constant term. Okay. Now it is clearly ax equal to 0 form. Given that ax equal to 0 has non-trivial solution or non-zero solution, therefore det A equal to 0. Okay, equate det A to 0. 1 minus lambda 2 3 1 minus lambda 2 3 1 minus lambda equal to 0. 1 minute. You need not solve complete problem. Just apply the operations C1 plus C2 plus C3. If you apply C1 plus C2 plus C3, you will get 6 minus lambda, 6 minus lambda, 6 minus lambda. Take 6 minus lambda common. From determinant, you can take an element common either from row or column. You can take 6 minus lambda common from first column. You'll get 6 minus lambda of 1 1 1 2 1 minus lambda 3 3 2 1 minus lambda. This is one value, this is other value. Suppose this value is A, this value is B, AB equal to 0. If AB equal to 0, either A is 0 or B is 0. That's why 6 minus lambda equal to 0, lambda equal to 6. If lambda is 6, then the system possesses non-trivial solution. Otherwise, you can go for expansion. Chandani, Sinha, either you can apply row operations or column operations, doesn't matter. It is not rank, it is determinant procedure. In determinant, you can apply either row operations or column operations alternatively, no problem. But while finding rank in echelon form is restricted to only one set of operations. That's why I have applied row operations continuously. Okay? Now, next, dimension of null space. Because you can substitute lambda value in the equation itself, no problem. You have to go for 4 trials now. First option, second option, third option, like that. Trial and error. Now, dimension of null space. What is dimension of null space? Dimension of null space is nothing but nullity. Okay? To calculate nullity, first you have to calculate rank. So first calculate rank. 0 1 1 1 minus 1 0 minus 1, 0, minus 1. That is matrix A. Now, R1 interchange with R2. 1, minus 1, 0. 0, 1, 1. Minus 1, 0, minus 1. Next, R3 plus R1. 1, minus 1, 0. 0, 1, 1. Minus 1 plus 1, 0. 0 minus 1, minus 1. Minus 1 plus 0, minus 1. Next, R3 plus R2. R3 plus R2. 1 minus 1, 0. 0, 1, 1. 0, 0, 0. Clearly, matrix is in echelon form. Rank of A is 2. Number of variables equal to number of columns. Therefore, dimension of null space. One. 3 minus 2, 1. Therefore, dimension of null space is 1. Okay? Nullity is 1. Next problem. It is a problem designed on concept of basis. 3 vectors are provided, E1, E2, E3. Okay? E1, E2, E3 from an orthogonal basis of a 3-dimensional real space R cube. So R cube, one 3-dimensional space. For that 3-dimensional space, E1, E2, E3 are members of the basis. Please understand the question. B is the basis that consisting of E1, E2, E3. That basis is basis of a 3-dimensional vector space. Okay? Now, the vector 4, 3, minus 3 belongs to R cube can be expressed as. I have explained you the concept of basis. So here, in this problem, basis B consisting of 3 vectors. 3 vectors of dimension 3. If the basis consisting 3 vectors of dimension 3, minus 2, 0, 1. Please concentrate. Your vector is with 3 components. So 3-dimensional vector. Okay, your vector is with 3 components. So your vectors are 3-dimensional vectors. So this is E1, E2, E3. E1, E2, E3 are members of the basis. As per the concept of basis, if you take any vector from your vector space, that vector is possible to express as a linear combination of E1, E2, E3. That is the concept of basis. You all know. Okay. Here, what is the vector belongs to the vector space? 4, 3, minus 3. If 4, 3, minus 3 is a vector from your vector space, you have to express this vector in the form of A E1 plus B E2 plus C E3. So A into 1, 0, 2 plus B into 0, 1, 0 plus C into minus 2, 0, 1. Okay. So now what are the values of ABC? what is the value of A, what is value of B, what is value of C. Our job is to calculate ABC values. What he has given? Minus 2 by 5 E1, 3 E2, 11 by 5 E3 means what? E1, E2, E3 are nothing but these vectors, na? Our job is to calculate A value, B value, C value. Do one thing. Equate LHS with RHS. What is LHS? 4, 3 minus 3. 4, 3 minus 3 equal to, what is RHS? A plus 0 plus minus 2C. Next, 0 plus B plus 0. Okay, next, 2A plus 0 plus C. Understood? So from second equation, I mean this entry B value 3. Catch my point? B value 3. So BE2, 3E2 in which option? Verify. 3E2 is in which option? Plus 3E2 is in which option? Plus 3E2 is in which option? Not first option, not second option. So either third option or fourth option. Either third or fourth. Understood? So answer is either third option or fourth option. We can understand that point. Understood? Now, next, come here. First equation. I am equating first one. A minus 2C equal to 4. Third equation. 2A plus C equal to minus 3. Do one thing. I am writing 4A plus 2C equal to minus 6. Any problem? 2A plus C is minus 3. So 4A plus 2C equal to minus 6. Add both. 5A equal to minus 2. A equal to minus 2 by 5. If A is minus 2 by 5, observe 2 into minus 2 by 5 plus C equal to minus 3. So C equal to minus 3 plus 4 by 5. So minus 11 by 5. Okay. So A is minus 2 by 5. B is 3. C is minus 11 by 5. So D option is correct. C is incorrect. Understood the concept? It is completely designed on concept of basis. Sir, how you have written this spanning? I have written linear combination AE1 plus BE2 plus CE3. When it is possible? If your vector space is three-dimensional, you have three vectors, then that linear combination is possible. Sir, suppose your vector space is three-dimensional, but in the basis you have only two vectors, then this spanning is not possible. You can write only subspace. Catch my point? Next. Here, most of the students get confused. Just to confuse you, they have designed the problem like that. An orthogonal set of vectors having a span contains orthogonal set of vectors having a span contains PQR. where P is given, Q is given, R is given. Most of the students try to understand this concept. They will try, sir, what is spanning, what is PQR, how to solve it. Actually, problem is the keyword is here. This is keyword. What he said in the problem, he told that matrix a set B is a basis containing three vectors PQR. Okay, here P is one three-dimensional vector, Q is one three-dimensional vector, R is one three-dimensional vector. Those entries are available. Here he has given. Okay. Suppose there is a basis which contains three vectors PQR. Actually, this PQR are three independent vectors in a three-dimensional space. In a three-dimensional space or not? In that three-dimensional space, suppose PQR forms a three-dimensional space like this. In that three-dimensional space, what are the set of orthogonal vectors? Our job is to identify this orthogonal vectors. Suppose PQR forms one three-dimensional space. In that three-dimensional space, which of the following are orthogonal set of vectors? Okay, so most of the students are try to get the solution from PQR. PQR has no role at all. The problem is designed based on orthogonal set. Orthogonal set means perpendicular vectors. From the options you have to solve the problem. What are perpendicular vectors in the given options? In the given options, which two vectors has dot product is 0? If you take first option, first vector dot product with second vector -6, option A, I am verifying, -6 -3 +6 dot product with 4 -2 3. What is the result? -24 +6 +18, 0. Dot product is 0. Therefore, first option is correct. Okay. It is actually problem of vector spaces. Right now, from 2016 onwards, vector spaces are not there. V1, Imam Basha, already they have mentioned R cube. Clearly, three components are in your vectors. Basha, in your basis, you require three vectors. But for orthogonal set, two vectors are perpendicular. You can say that those two vectors are orthogonal. Na? Mahima, you watch the recorded video of first lecture. In first lecture, I have explained what are orthogonal set, what are orthonormal set. Observe. If V1, V2 are four-dimensional subspaces of a six-dimensional vector space. So your vector space is six-dimensional vector space where V1 is four-dimensional subspace and V2 is four-dimensional subspace. Please concentrate. Actually, your vector space is of six-dimensional. V1 has four-dimensional subspace means there are only four vectors. Four vectors in V1. Four, hello, not R power 4. Yesterday I have explained so many times. In a basis, if you have only two vectors of dimension 4, 1 entry, A2, A3, A4, A1, B1, B2, B3, B4, A5, A6, B5, B6. What does it mean? In this space, you have vector has dimension 6. Vector has dimension 6, matlab it is a six-dimensional vector space. In that six-dimensional vector space, it is a subspace. Which one? This one. This is a subspace. Why this is called subspace? If you have six independent vectors, you can call it as basis for the space of R power 6. But you have only two vectors. Two vectors, matlab, it is a subspace. Subspace of a six-dimensional vector space. Catch my point? Come here. Here, V1 and V2 are four-dimensional subspaces. Matlab, in V1 you have four vectors of dimensions 6 and V2 also consisting of this vector has dimension 6. Right. V2 is also consisting four vectors of dimension 6. So dimension of V1 is 4. Dimension of V1 4 means V1 consisting of four vectors. 1, 2, 3, 4. V2 consisting of four vectors. Both are consisting only four vectors. But dimension of the vector is 6. Okay. So dimension of V1 is 4. Dimension of V2 is 4. And the smallest possible dimensions of V1 intersection V2 is, you have to find out dimension of V1 intersection V2. Okay, now you have one question. I am asking one question. Your vector space is a six-dimensional vector space. Okay, sir, how do you know that? They have given V1, V2 are subspaces of a six-dimensional vector space. Now, my question is, if your vector space is a six-dimensional vector space, your base is consisting of how many vectors? That is my question. 6. Gauravi. If V1 here vector space is six-dimensional vector space, then your basis must contain 6 linearly independent vectors. That's why I am writing, even though V1 and V2 are subspaces, but the basis must contain 6 independent vectors of dimension 6. What is basis? That basis is nothing but union of this V1, V2. Okay, that's why I am writing dimension of V1 union V2 equal to 6. Sir, how do you know that? Vector space is of 6-dimensional vector space. Therefore, the basis contains maximum 6. Not more than 6. Not less than 6. Exactly 6. Exactly 6 linearly independent vectors in your basis. That's why dimension of V1 union V2 is 6. We have one formula. Dimension of V1 union V2 equal to dimension of V1 plus dimension of V2 minus dimension of V1 intersection V2. This is known, this is known, this is known, this is unknown. Send V1, V2 this side. Dimension of V1 intersection V2 is 8 minus 6, 2. 2 is the answer. Observe. It is given that x1, okay, Sandeep, maximum conceptual questions I have covered in the class. Okay, wherever problematic questions are required, we are going to discuss. In eigenvalues and eigenvectors are entirely conceptual along with practice questions. Okay, mainly in these conceptual questions, most of the students get confused and they will mark wrong options. That's why I'm giving the clarity. Sir, what is this dimension of V1 intersection V2 is 2? What does it mean? What does it mean? Very simple. You have written 4 vectors here. Here 4 vectors you have written here in V1 and V2. In that V1 and V2, 2 vectors are common. Okay? 2 vectors are common. Suppose this vector and these vectors are in V1, the same vectors are also available in V2. Then what happened? Here total 4, here total 4, total 8. In that 8, 2 are repeated. You are subtracting, then total 6. Those 6 are members of your basis. That's why dimension of V1 union V2, I have written 6. Catch my point? If your vector space is 6-dimensional vector space, for that 6-dimensional vector space, you require 6 independent. Those 6 independent are nothing but members of your basis. So those 6 are available in V1 as well as V2. You can pick up. So here you have 4 available, here 4 available. Sir, in that 4 and this 4, total you have 8. Sir, union matlab all 8 you have to write. Yes, you have to write. But any vector is repeated. Can you write again? You can't write now. You are going to eliminate that. That how many are repeated? Repeated matlab in V1 and V2 commonly available. Commonly how many are available? 2 are common. Those 2 are nothing but members of your V1 intersection V2. V1 not union, intersection. Catch my point? Come to the problem. Next problem. This is also a conceptual question. Sir, it is given that x1, x2, xm are m non-zero orthogonal vectors. Please concentrate. Orthogonal vectors, m non-zero orthogonal vectors. The dimension of vector space, spanned by 2m vectors. Concentrate. First, understand the question. It is given that there are m non-zero orthogonal vectors. Sir, what are the speciality of these orthogonal vectors? Please concentrate. If m non-zero vectors are orthogonal vectors, they are 100% linearly independent. If you take these m vectors in one matrix, if you calculate determinant value, that determinant value is 100% non-zero. Best example, if you take 3 orthogonal vectors, 1 0 0 0 1 0 0 0 1, perfectly these 3 vectors are orthogonal. 1 0 0 x-axis, 0 1 0 y-axis, 0 0 1 z-axis. If you calculate determinant, 100% determinant is non-zero. Observe. Now, if your vectors are orthogonal, 100% they are linearly independent. So here, how many vectors are linearly independent? Tell me now. How many vectors are linearly independent here? M linearly independent vectors, because he has mentioned m vectors are orthogonal vectors. So m are linearly independent. Now, our job is to calculate dimension of a vector space. Our job is to calculate dimension of the vector space spanned by 2m vectors. In that vectors, look at once, what are the vectors? x1, x2, xm. Then minus x1, minus x2, minus xm. You have 2m vectors are available. In that 2m vectors, m vectors are non-zero orthogonal vectors. Concentrate here till here. These are all non-zero orthogonal vectors. And remaining m vectors are, out of 2m vectors, first m vectors are non-zero orthogonal vectors, next m vectors are also non-zero orthogonal vectors, but remaining m vectors are depending on these vectors. Sir, how can you say that they are dependent? A bar minus a bar, dependent or independent? A cap and minus a cap, both are dependent, na? Okay, so if these vectors are dependent, whenever you are going to arrange in a matrix and calculate rank, then by applying operation minus x1 plus x1, minus x1 becomes 0, minus x2 becomes 0, minus xm becomes 0 vector. Completely m vectors are going to become 0 vectors. M vectors are maintaining as non-zero vectors. So what is rank? M. If rank is M, dimension of the vector space spanned by 2m vectors are M only. It is nothing but rank. So answer is M. Understood? Mr. Akhtar, I have given example here. 3 vectors I have given. If you write in a matrix 1 0 0 0 1 0 0 0 1, next 3 vectors are minus 1 0 0 0 minus 1 0 0 0 minus 1. Here these 3 vectors are x1 x2 x3. This is x1, this is x1 x2 x3, this is minus x1 minus x2 minus x3. If you apply the operation c4 plus c1, c5 plus c2, c6 plus c3, you are going to get 1 0 0 0 1 0 0 0 1 0 0 0 0 0 0 0 0 0. What is rank? Vishal Kumar, Mr. Akhtar. 3 only na? So the dimension is here 3. So here dimension is M. Understood? Next, the vectors 2 2 0 and 3 0 2 and 2 minus 2 2 are linearly dependent and basis of R cube, or linearly independent and basis of R cube. Which one? You have to examine. Okay, first you try. I have explained all the concepts. First you try how to examine. Very good. The vectors 2 220, 302, 2 minus 2, 2 are linearly independent of and basis of R cube, or linearly dependent and basis. Which one you have to identify? How to identify? Very simple. Just calculate determinant. Okay, calculate determinant or rank, whatever it may be. If you calculate determinant value here in this problem, 220, 302, 2 minus 2, 2. Now 2 of 0 plus 4 minus 2 of 6 minus 4, 8. 6 minus 4 is 2, 2 to 4, finally 4, non-zero. Non-zero means the set of vectors are linearly independent. If the set is linearly independent, then definitely these three vectors forms a basis for R cube. Okay, why R cube? Because your vector is three-dimensional vector, na? That's why. Next, for what value of k the set of vectors forms a basis? Same concept. Here, the vectors are independent or forms a basis or not. Here, for which value of k the set of vectors forms a basis. Way of questioning is different. Okay, concept is same. Just calculate determinant and not equal to 0. Not equal to 0. Not equal to 0 because they have mentioned basis, na? Not equal to 0. Calculate determinant. K11, 011, K0K must be non-zero. That is K of K minus 0 minus 1 of 0 minus K, 0 minus K plus 1 of 0 minus K not equal to 0. That implies K square plus K minus K not equal to 0. K square must be non-zero. So K must be non-zero. So the set of vectors forms a basis when any real number except 0. So K must be a real number system minus 0. Okay, if you delete 0 from your real number system, for all values of R, it forms a basis except 0. So you can write simply any non-zero value of K, any non-zero value of K, it forms a basis. Okay? Observe. Because it is not a function, Baba. Domain kya ji? A domain, codomain range nahi. For which value of K the system of equations gives us a basis. For which value of K? K value should not be 0. It is not, it is belongs to a mistake, typing mistake. It is belongs to, X belongs to R cube. X1 plus X2 plus X3 equal to 0, where X transpose. Which of the following is true? These two vectors forms a basis for subspace or linearly independent set but not span. Therefore, it is not a basis, or X is not a subspace, or none of the above. Observe. Similar problem, I think same problem or similar problem yesterday we have discussed. Only one equation, huh? X1 plus X2 plus X3 equal to 0. You can write in matrix form 1, 1, 1, X1, X2, X3 equal to 0. What is rank? Number of variables. Okay. Number of variables are 2. Rank is 1. A number of variables are 3. Rank is 1. So free variables 3 minus 1. 3 minus 1 means 2. 1 minute, observe. In the options we have, okay, 0 is in second place and 0 is in third place. Okay. No, I am verifying because which variable I have to take K1, K2 like that. Because we have two free variables now. First, the equation is X1 plus X2 plus X3 equal to 0. Called it 1. You have to take two variables as free variables. Let us assume X2 equal to lambda, X3 equal to K. Now, X1 plus lambda plus K equal to 0. X1 equal to minus lambda minus K. Therefore, X1, X2, X3 is minus lambda minus K, lambda K. That can be written as lambda into minus 1, 1, 0 plus K into minus 1, 0, 1. Lambda into minus 1, 1, 0, K into minus 1, 0, 1. Now, basis equal to minus 1, 1, 0 and another vector minus 1, 0, 1. Bracket close. Look at the dimension of the vector. Look at the dimension of the vector 3. If dimension of the vector is 3, your basis must contain 3 independent vectors. But your basis is not contains 3 independent vectors. That's why you have to write B is a basis for subspace. B is basis for subspace of a vector space R3. For a 3-dimensional vector space, it is a subspace. Basis for the subspace of R3. Understood? So, which option? First option. Observe, let A be M cross N matrix with rank R. Let A be M cross N matrix with rank R. The dimension of space of solutions of the system of equations. Simple problem, poll is not required. Directly you can answer. Number of columns minus rank. Number of columns are n, rank is r, n minus r. Understood? Space of solutions are nothing but nullity. Nullity or dimension of null space or dimension of space of solutions, all are same. Okay, this is eigenvalue concept. Next we can discuss. Now, let me explain what is eigenvalue and what is eigenvector. Yeah, problems, entire concepts, properties, everything we are going to discuss tomorrow only. But today I would like to give introduction. Eigenvalues and eigenvectors. Now, A is a square matrix. A is a square matrix. X is a non-zero vector. A non-zero vector. A non-zero vector equal to lambda x. This lambda is called eigenvalue. This non-zero vector is nothing but eigenvector. Observe here. Please understand the concept. Ax equal to lambda x. Simple logic. A is a square matrix of order n. For every square matrix of order n, there exists a non-zero vector x such that Ax equal to lambda x. Then lambda is called eigenvalue of A and x is called corresponding eigenvector. Sir, how to calculate eigenvalues? Means you are going to use the concept determinant of A minus lambda equal to 0. In mathematics, we are going to use the concept determinant of A minus lambda equal to 0. In control systems, you are going to use Si minus A equal to 0. Whether you are writing determinant of A minus lambda equal to 0 or determinant of Si minus A equal to 0, characteristic equation is same, the roots are same. This is our practice, this is your practice. Okay? Both gives same roots. Now, observe. So why determinant of A minus lambda gives roots? Why not determinant of A minus lambda non-zero? Why only determinant of A minus lambda equal to 0? Simple logic I will explain. Ax equal to lambda x. Then lambda is called eigenvalue of A and x is called corresponding eigenvector. The logic is Ax equal to lambda x means Ax equal to lambda ix na? Because x multiplied with identity matrix gives itself na? So Ax equal to lambda x is nothing but Ax equal to lambda ix. Now this can be written as A minus Ax minus lambda ix equal to 0. Ax minus lambda ix equal to 0. This can be written as A minus lambda I of x equal to 0. A minus lambda I, A is a matrix. A is a matrix. Lambda is also a matrix. Because I is identity matrix, lambda is constant. If you multiply identity matrix with constant, you will get a matrix. So difference between two matrices is also a matrix. If A is n cross n, A minus lambda is also n cross n. Observe here. A minus lambda I of x equal to 0. It is an n cross n matrix because A is a square matrix. If A is square matrix, lambda is also a square matrix because addition and subtraction are possible only when they are of same order. That's why A minus lambda is n cross n. If A minus lambda is n cross n, x must be n cross 1. Why n cross 1? It is a column vector. A minus lambda I and x are in multiplication. Multiplication is possible only when number of columns in prefactor must be equal to number of rows in postfactor. Then only they are comfortable for multiplication. Okay? Now come to the point. In the first slide, I have given clearly non-zero vector. What is the meaning of non-zero vector? Non-zero vector gives us non-zero solution. Non-zero solution. Non-zero vector gives us non-zero solution. Non-trivial solution. Yes. Non-trivial, non-zero and infinitely many solutions all are same. Okay. Come to the point. Look at the system. Look at this system. This system is homogeneous system or non-homogeneous system? Homogeneous system. Here, system is homogeneous and x is a non-zero vector. X is non-zero vector. X is a non-zero vector means it gives non-trivial solution. In a homogeneous system, x is a non-zero vector means compulsory system possesses non-trivial solution. If non-trivial solution, if the system possesses non-trivial solution, 100% determinant value of your matrix must be equal to 0. Determinant must be equal to 0. So determinant of your matrix, what is your matrix? A minus lambda I na? A minus lambda equal to 0. That's why to calculate eigenvalues, we are going to use the concept determinant of A minus lambda equal to 0. If determinant of A minus lambda equal to 0 is the characteristic equation which gives the roots, those roots are nothing but eigenvalues. If determinant value of A minus lambda equal to 0, this homogeneous system possesses non-zero solution. If the system possesses non-zero solution, determinant value of A minus lambda equal to 0. It is necessary and sufficient. If the homogeneous system possesses non-zero solution, determinant value of A minus lambda equal to 0. If determinant value of A minus lambda equal to 0, then the non-homogeneous system, the homogeneous system possesses non-trivial solution. Understood? Sir, if the system is homogeneous, it has two possibilities. One is trivial, one is non-trivial. But in this problem, you are talking about only non-trivial. Why not trivial? If the system possesses trivial, your solution gives us zero solution. If the system possesses trivial solution, then all the variable values are 0, x1 0, x2 0, x3 0 or xyz 0. So 0 vector cannot be treated as eigenvector. But the definition itself, we have mentioned clearly, x is a non-zero vector. That's why even though your system is homogeneous, in eigenvalues and eigenvector problems, you will get only non-trivial solution, only non-trivial. That's why determinant value is always 0. Determinant value of A minus lambda is 0. Catch my point? This is the conceptual background about eigenvalues and eigenvectors. Actually, practically, eigenvalues and eigenvectors concept has a lot of applications. You have in your television, you are watching 100 television channels, more than 100 channels, right? Every channel has different frequencies. Understood? If you, for different frequencies, you will get different channels. That means each frequency vector is nothing but eigenvector. In the antenna, you are going to adjust the values for different channels, there are different waveguides. So each waveguide value is nothing but eigenvalue. Whenever this waveguide value synchronize with corresponding frequency, then automatically the signal will come your television. Particular channel will come. That means the waveguide value is nothing but eigenvalue. Corresponding frequency vector is nothing but eigenvector. Okay. Now, for example, if you take motorbike, it is a mechanical system. Earlier, communication system. Okay. Now, you have a mechanical system. If you have a motorbike with 4-gear system, 4 gears. Suppose if you change gear 1 to gear 2 or gear 2 to gear 3, whenever you change the gear, the chain changes from one wheel to another wheel. Number of teeth on the wheel, whenever you change the gear, acceleration changes. Whenever you change the gear, the chain changes from one wheel to another wheel. Number of teeth on the wheel is nothing but eigenvalue. Number of teeth on the wheel is nothing but eigenvalue. Corresponding acceleration vector you have, that vector is nothing but eigenvector. The stability of that mechanical system we can analyze based on eigenvalues and eigenvector concept. Practically in simulation panel, it is you are going to write linear equations and you can visualize. These are the applications of eigenvalues and eigenvector concept. Tomorrow we are going to discuss problems related to eigenvalues and eigenvectors. Okay? Any queries? One or two queries. Sir, the vectors are in a basis are not always linear. Are always linearly independent is correct. Not always is 100% wrong. Always independent. Sir, third and fourth problem you have discussed similar type, because both the problems B is depending on A. It is correct. Correct. 100% correct. Not is 100% wrong. Hyderabad Vijay. Sandeep, you can download after 1 hour. Now, after 12:30, you can download. Okay? Right. One question again, because it is a problem designed on simple concept. In matrix theory, PQ not necessarily equal to QP. Matrix multiplication not satisfies commutative property. Okay, so which one of the following equations are correct? Correct or incorrect? PQ, P of Q plus R equal to PQ plus PR. That is correct. But they have given RP, so it is incorrect. First option is incorrect. P minus Q whole square equal to P square minus 2PQ plus Q square. That is incorrect because P minus Q whole square matlab P minus Q into P minus Q, P square minus PQ minus QP plus Q square. Okay, so here they have given P square minus 2PQ, that is incorrect. Determinant value of P plus Q equal to det P plus det Q, that is absolutely wrong, not necessary. So last option is correct. Vikas, got it? Thank you. Good night.